Hello， 有没有声音了？等一下。Hello everyone. I'm Mike. Okay, I'm here in this video because I'm not available on the meeting tomorrow. I'm recording this video the night before the real meeting. So just let me explain to you guys our prototype, the design of our prototype for this MPU4 project, which is, as you can see here, this is the rough sketch of our so-called breeze turbine. It is basically a turbine generator floating in the water. Then it is hold static relatively to the water using anchors. This is the rough sketch. The real thing should look a lot cooler, but this is just my drawing skills. Okay, so breeze turbine are basically separated into four main parts, where we can design them separately, which is one of them are the turbine generator itself, second the connection pole, the third the floating base, and then the final one is the anchor. So let us start one by one. First of all, let's go to the turbine generator. The turbine generator itself are separated into two main parts, which is the turbine leaf and then the generator. So the turbine leaf are basically any generic turbine leaf that you see on the turbine generator, but since we are going to design it, we will do it step by step. Okay, so the hub, which is the cylindrical cone-like head of the turbine leaf, and then this is the bottom view, which means at the bottom it has a hole drilled into it for what I call a screw spot. Later can be screwed onto the central cylinder, which is the central cylinder is the main part of the turbine leaf, which the hub and then the leaves will be assembled onto the cylinder so that it becomes one. So as you can see here, the central cylinder has a screw for the hub, and then it has a coupling side for blades, turbine blades, which means it is designed like this. It has two cutout, which allows the specific design turbine blades to insert, and then it turns to a specific direction to lock in position. Okay, so you can imagine the blade goes in straight, but there is a passageway for this extension to turn and to rotate and lock the blade into position. Okay, so that's the coupling mechanism for the blades into the central cylinder. So next we have the generator itself. Okay, for the generator, it has two main parts, which is the rotor and stator. The rotors houses magnets, as you can see here. The magnets are placed with alternating poles, and then we have stator, which is the house for wire coils, the copper wire coils. This is just like any generic generator, which uses electromagnetic principle to produce electricity. So the rotor, which means it will rotate. The stator means it is static, which means when the turbine rotates the main power shaft, the rotor rotates but the stator don't, because it is being fixed static to the outer casing, and at the same time it has a bearing at the center, so it neutralizes the rotating motion of the power shaft. So next, excuse me. from this is some complex drawings just for our own understanding, but then for the information that you need to know is that it should work theoretically, and then by theory one complete set of generator should have one stator and two rotor. It should produce about 8 to 16 volt of electricity. Okay, so next let's move on to connection pole. Connection pole, which means it's just a pole that connects the turbine generator to the base, which is the floating base. The main purpose for this connection pole is to allow the wires, which is the electricity, to be connected from the turbine generator to the floating base where the battery will be at, which is the storage of our electricity. Okay, so we have not much to talk about, but then the recommended material of the connection pole should be carbon or low alloy steel, as you can see here. Okay. For pressure resistance purpose, the diameter and the length of the connection pole should be in specified ratio, so that when the pipe gets longer, it also gets thicker in order to withstand pressure underwater. Okay, so next we have floating base. Floating base is a base that allows the turbine to be floating in the water, and at the same time it doesn't touch the sea floor. Okay, so for our testing purposes, we plan to build the floating base by using the safety buoy, which means the safety buoy, that you will see at the beach, used to save people. And the base, we can use PVC or some polyester material to build it just at the middle, and then somehow we tie the safety buoy to the middle base. But for the real thing, we plan to separately produce the floating devices and the floating base, and we connect the floating devices to the floating base by using snap hook, which is some might call the mountain hook. You can see on climbers or construction workers that has a very high weight rating, which means it can withstand very high force, pulling force. Okay. Plus, after the discussion a few days ago, within the team we have decided to add in a place for power storage, which means battery. It is being amended lah. In the design here, we don't see the place for battery, but then it will be a place for battery for power storage. Okay, so last but not least, let's move on to our anchor. So first you can see the position of our anchor. Originally we tried to make the base more longitudinal, but then turns out we have a round floating base design, so the position of the anchor are being reconsidered lah. But then the modification are in progress. Okay, anchor, as everyone already know, it is just a device that helps to keep the whole thing in place in water. So as you can see here, we have a lot of different ready-made sketches of anchor, and then we can purchase them online. But another option, we can produce them by ourselves. These are two rough sketches of anchors, and I have already asked the designer to produce a more detailed sketching. But then this is what we have now. As you can see here, the main design are equipped with a lot of water passage, which means these holes are hollow, which allows water to flow through without much resistance, and then it does the job lah. It grabs onto the seabed so that the whole thing stays in place. And then the material recommended are this. But most probably we will use steel or iron, because aluminium, titanium, and Inconel are very hard to manufacture and also to make shift. Okay, so these are our current progress of the rough design. Now we are going for more detailed design, meaning we are searching for more potential materials, pressure ratings, tension ratings, torsion ratings of our design, and then at the same time we are trying to modify our design so that it fits our purpose better. Okay, so last but not least, we are trying to separate our design into two specific parts, which means we have one testing design and one prototype design. The testing design is basically the prototype of our prototype. Yeah, the prototype is our real thing. For now, estimated the testing design, which is the prototype of our prototype, should be the generator of our prototype should be half the height of a 2-liter water bottle, and it should be also half the width. The width of the generator is also should be half a 2-liter water bottle, and the maximum weight should be about 5 kg. And then the real thing, which is our prototype, should be about 20 kg maxed. Yeah, max 20 kg. Like, we cannot go higher than that. Okay. So I think that's all for our current progress of our RND for prototype. Okay, thank you.